Good morning, Year 8. I hope we're all safe and well. Thanks again for engaging with these online lessons. Please send me that message on Show My Homework so they can put you on our online register, and I will get the reward points out this Friday for you again. Now, today's lesson is going to be based on two My Maths activities for our assessment. You will need a calculator as well today. They'll be really handy. And again, if you need help, pop in touch with me on red@theroyal.school and save submissions of work for just Show My Homework, please. So today we're going to have a look at circumference and area of a circle. So we're going to need to know some key terms about circles today before we can go much further. So it'd be really handy if you guys could get yourselves a drawing of this diagram that we're going to have a look at now. These are going to be some of our key terms for today. So a circle is a set of points equidistant from the centre. Equidistant means an equal distance. That means that if you take a point from the centre of the circle to the edge of it, wherever you do that, it's always going to be the same length. So, centre of a circle and the circle drawn around it. And we have some special terms. So the distance around the outside of the circle, so that's in essence the perimeter of the circle, has a special name called circumference. So circumference is the distance around the outside of a circle, highlighted in orange now. The radius of a circle, another key term, is the distance from the centre of a circle to the circumference. Now it doesn't matter what direction that's drawn in, but this one here, we've got a line there from the centre to the edge. This one just goes exactly horizontally across, but it could go in any angle at all. So we could still have a radius if I had one going up here. This in red would be a radius as well. Or if I was to draw one down in green here at a slight angle, this would be a radius as well. So the angle doesn't matter. So a radius is a distance from the centre of a circle to the circumference. And finally, our last key term about circles today is going to be a diameter, which is the distance across the width of the circle through the centre. So that's a line all the way across from one edge to the other that has to go through the centre. So this is a diameter. Now there are other parts of a circle as well that we might need to know, but we're not going to have a look at those just today. So these are the key terms we'll be using very, very often in today's lesson. So you need to know what is a circumference, what is a radius, and what is a diameter. As I said, it'd be a great idea to have a copy of this diagram in your book so you can refer back to it when you need to during the examples. Now, when we're dealing with circles, there's another number or term that we are going to be using very, very often. It's a very special number in mathematics, and it's called pi. Now, this is the symbol for pi that I'm highlighting in green at the top. It's a Greek letter, and it looks very much like a capital letter T with two vertical lines instead of one. So this one's an italics one, so it looks quite posh, but if you just draw a horizontal line with two vertical lines come down from it, you've got pi. And it's not spelt like the pie you would eat, it's just P-I for the spelling of this pi. Now, this number is really, really important in mathematics because for any circle, the circumference, remember the distance around the outside of a circle, is always just over 3 times bigger than the diameter. Now, this 3 and a bit times bigger isn't something that mathematicians have decided on, it's something that occurred in the natural world. So this is why pi is really special. It's not something that people have made up, it's something that was always existing in the natural world before mathematics ever came along, but mathematics just assigned this number to it. Now, any circle then, whether it's the top of a tin of beans, the top of a glass, the top of an oil drum, whether it's a ball, the cross-section of it that you're looking at, or even going upwards and the orbit of a planet or the cross-section of a sun, then you're going to find that this is the case. The distance around the outside of that circle is always just over 3 times bigger than the diameter. And this just over 3 is assigned this number that we call pi. Well, why do we use this symbol or this word pi instead of the number 3 and a bit? Well, this is because 3 and a bit is very, very specific, but also a very odd type of number. So this number pi is used because we can't write the number exactly. Now this is a very particular type of number in maths called an irrational number. You won't need to know that term just yet, but pi cannot be written exactly. It's a long decimal number, as we can see here, but it never stops going, and there's never any parts that continually repeat themselves. So actually, whenever you write down pi as a number, you're rounding it, which isn't going to be accurate. If you were talking orbits of planets or even galaxies moving around in space, then if you were to write pi to 200 decimal places, then actually that might not be accurate enough. So quite often we use the symbol pi here, and in our title of this slide to represent that number. So this number is just 3 and a bit. Don't get put off by the symbol, but it never stops going as this decimal, and we would sometimes need it really, really accurate, so use the symbol in place. So how do we go about using this in a sum? Well, we're going to have to use an approximation quite often for pi, and that means just a rounded value. Now, so a lot of questions are quite handy because they will tell you what approximation to use. So if you were doing a really rough approximation, if you're doing a mental calculation to just check that your answer is suitable, you could use 3. It's not very accurate though. Quite a lot of questions will ask you to use 3.14 or maybe even 3.142, or less commonly 22/7. Again, we're using quite a bit of calculator use here, so don't get put off by the fraction being in there. You shouldn't know where the fraction button is on your calculator and be able to type that in, or just use a 3.14. Or you could better use this pi button on your calculator. Now, the pi button on a lot of the Casio classwiz that I know a lot of you have is down at the bottom of the calculator, on the bottom row, the middle button. The middle button actually should say times 10 to the power of x, which doesn't look a lot like pi at all. But what you should notice is that above it, in yellow writing, you have the pi symbol there. So it's not on the button itself, but just above it in yellow. So to get pi on your calculator, you're going to need to press the shift button, which is the top left, and that gets you into the yellow functions. And then you can press that times 10 to the power of x, and you should see the pi button come up on your calculator. You don't need to press the buttons both at the same time. Press shift first, release it, then press that times 10 to the power of x button, and you should see pi come up on your calculator. Now, most questions will tell you what approximation to use. In the case that they don't, I would definitely always be trying to use that most accurate version. So use the pi button on your calculator. It's going to be the best way through these questions. So the pi button, again, stops you having to write out the decimal number all the time. Mathematicians are sometimes a little bit lazy, so using the pi symbol will help us to cut down what we're writing for our calculations. So we come on to the main formula that we need to use for this part of the lesson. So this is how to work out the circumference of a circle. So the circumference of a circle, the distance around the outside of a circle, its perimeter, equals pi times the diameter. That's it. The circumference is 3 and a bit times whatever the diameter is, and we're done. It's quite a simple formula to use, but we're going to need to remember it. So I'd definitely write down what's in the box here, or if you're quite confident with this, we could actually rewrite this in an algebraic way to make a different way of writing the formula. So we could just have C equals pi d, and we can see here there is circumference has been replaced with the letter C. Pi is still in there, we need that 3 and a bit number definitely, and diameter has been replaced with the letter D. And another thing to remember there, in our formula that we've written at the bottom, just remember that we quite often have hidden time signs in algebra. So the time sign here has disappeared, and the fact that these two symbols are right next to each other, remember, in algebra, means that we're timesing them together. So these two formulas mean the same thing. So make sure you've got a copy of one of those at least written down in your book, because we're going to be needing that going forward. So putting this into practice then, we're being asked here to find the circumference of this circle. A couple of things to watch out for. We've been given a pi as 3.14 here. It says use pi equals 3.14, so we must do that in this question. As we'll see in a moment, if you use pi exactly on the calculator, you get an ever so slightly different answer. So watch out for what the question's asking for here. So write out our formula. Circumference equals pi times diameter. Well, circumference is what we're after, so we can't fill that in yet. Pi, we're being told, is 3.14. And what's the diameter? Diameter is a line from one edge of the circle to the other through the centre. So lovely, we've got our diameter here is 8. So we want 3.14 times 8. Pop it in on the calculator and you get 25.12 centimetres. Done. Now, if you were to use pi accurately on the calculator for this, you'd end up, if you excuse my mouse handwriting for a moment, you'd end up with 25.13274.123, which we can see is ever so slightly different. If you were doing this on my maths and it had asked for pi equals 3.14, you can see actually that our number is different when you get to these two decimal places, 25.12 versus 25.13. So it might not pick up your answer as correct if it's told you to use pi as 3.14 rather than accurately. So this bottom number is our perfect answer, but of course remember this is rounded, the number would actually carry on. But that's as much as my calculator will display at the moment. So just be careful on what the question's asking for here, whether to use pi accurately or use pi as a given number. So what if you're not given the diameter of a circle though? Well, that's quite straightforward. You'll always be given the diameter or the radius. So if you don't have the diameter, you'll have the radius of the circle. And the diameter of a circle is 2 times the radius. So we could write that again algebraically. The diameter is 2 times the radius. And you can pop that into the formula. We know circumference equals pi times d. But if the diameter is 2 times the radius, we could get rid of diameter and put 2r there instead. And that would give us a formula here. Circumference equals 2 pi r. It's not completely necessary to write that one out. I usually just use a straightforward formula and calculate what the diameter is. But if you really need to, you could write that formula out. Now, we're going to look at 4 examples here. And again, if you're feeling confident, you could work ahead and pause the video before you've tried each question. Unpause when you get the answer. But if you're not feeling as confident, then I'm going to run through the answers now. So here, we're going to use pi equals 3.14. We want to find the circumference of the following circles. So this circle here, we've got a line through it which is 4 centimetres. We'll have a look at what line that is in just a second. So to work out the circumference of this circle, let's write our formula. Circumference equals pi times diameter. We know that pi is 3.14. What's the diameter of the circle? It's a line from one edge to the other through the centre. So lovely, we have got a diameter, so that's 4. So we want 3.14 times 4. Pop it in on your calculator. Make sure we've got the units as our answer. Remember, circumference is a length, so we get 12.56 centimetres. Next circle. So write out the formula again. Circumference equals pi times diameter. Again, we know pi is 3.14, but we want our diameter of the circle. Now, a diameter of the circle is a line from one edge to the other through the centre. So actually we don't have a diameter here, we only have a radius. But what we can imagine is if this part here to the centre is 9, then the other part, the rest of the way, it'd be 9 as well. And then that makes our total diameter 18. So here we want 3.14 times 18. And that gives us an answer of 56.52 metres. Please excuse my email going off in the background there. So another example then. Here again, we've got this red circle now. So write out the formula, circumference equals pi times diameter. And then we're going to need to work out, well, pi is 3.14 still. And what's our diameter from one edge to the other? Yes, we've got it, it's 23. So 3.14 times 23. Pop on the calculator and pop our units on. Remember, our first question was in centimetres, so answer was the same. Second question was in metres, so answering the same. This one's in millimetres, so answers in millimetres. And final one then. Here we've got a blue circle. Write out the formula. Let's pop in our pi and our diameter and bring in here. If the centre to the centre to the circumference is 58 here, it's also 58 here. So our full diameter is 2 lots of 58 or 116. Pop it in on the calculator and we get 364.24 centimetres. And this is how we find our circumferences then. Now, how would you go and work things backwards, finding the radius, pardon me, given the circumference? So it says here use pi equals 3.14 to find the radius of the circle. So we know that the circumference is 2 times pi times the radius from earlier, or pi times diameter. We could work this backwards. Well, how would you get the radius on its own? Well, if you look at the original formula here, our radius has been times by 2 pi. So if you rearrange a formula, we do the opposite functions. So we could divide by 2 pi. So our radius would be the circumference divided by 2 pi. So our circumference here is 12, and 2 times pi, given pi is 3.14, we can pop on the calculator, and that would give us about 1.91 centimetres. Again, rounded to 2 decimal places here. So you could work things backwards if you were looking at the really top end of these activities. Now, final question for this part of the activity. Then we're going to have a look at circumference of a circle in a practical aspect. So here, the diameter of a bicycle wheel is 50 centimetres. You can see that on the diagram. How many complete rotations does it make over a distance of 1 kilometre? Well, if you think about a tyre turning, the piece of the tyre that actually touches the floor is the outside. So that's going to be our circumference of the circle. So we're going to need to know what the circumference is. We need to know how long the tyre is. If you sort of cut it up, we wouldn't want to do that to a real bike, but if you cut it up and laid it flat, how long is that tyre? So that's going to be the circumference of our circle. So let's have a look. Circumference is pi times diameter. Pi is 3.14. I'm going to use that here again. If it didn't ask in the question, actually, probably be better to use the accurate version, use that pi button on your calculator here. We're going to use it as 3.14 just to get some nice decimals up on the screen. So the circumference of the wheel is going to be 3.14 times 50. So actually it's 157 centimetres, about 1.5 metres is the length of this tyre. So every time the tyre goes round once, every time it makes a rotation, it travels 157 centimetres. So what we now want to have a look at is how many of those turns are going to be made in 1 kilometre. Now we're going to need to do a bit of a conversion here as well. 1 kilometre is 1,000 metres, we should know, which is great. But actually our length here is in centimetres, so that's no good either. So if you've got 1,000 metres, then that's going to be something in centimetres. So we know that there's 100 centimetres in a metre. So we need 1,000 times 100, and you get 100,000 centimetres in a kilometre. So we want to know how many of these 157s make 100,000. How many of one thing goes into another is a division. So we're going to do 100,000 divided by 157. And that's going to tell us, rounded, of course, down here because we want complete rotations. So if we get 636 point something, then we're going to need to actually round it down because we only want the whole number part for complete rotations. So 100,000 divided by 157 does actually give us 636.9. but we can't use the 0.9 because we only want complete rotations. We're not rounding upwards here. So that's how we'd solve this practical aspect of the question. I think there's one similar to this in My Maths. So there's one My Maths activity for the moment, and we're going to have a look at some area questions. Pardon me. Have a look at some area questions in our next lesson. So stick with circumference for today. So one My Maths activity for the moment. There'll be another circle lesson coming up for Monday. So this part of the lesson now is going to be assessed via a My Maths activity on circumference of a circle. So that's the only activity to have a look at today. So thanks for engaging with the online lesson. Please send me that message now on Show My Homework if you've not already, and get yourselves on My Maths. I can provide passwords if anyone needs, but you'll have to email me at red@theroyal.school to get those. Though you should have used those quite often at the moment, so you should be happy with them. And if you'd like to submit your score via Show My Homework, that'd be handy, but I can do assessments via My Maths as well. Thank you very much. Please get in touch with me if you've got any problems, and I'll speak to you again on Monday's lesson, where we're going to have a look at the area of a circle, so the second part of the learning objective that we've got on these slides. Thank you very much.